Hey there, everyone. My name is Ryan Schul. Welcome to my channel. This is all about data science, machine learning, artificial intelligence. I tend to focus a lot on financial topics, but sometimes deviate from that and try to analyze different types of data sets. I think it's very interesting to do different types of analysis, and um, I kind of thrive on this stuff. It's kind of a passion for me. So if it's not financial related and it's something else, I still find a lot of these things very interesting. And this one is very interesting. So I came across some airline data that I want to showcase to you guys and share my findings with you. I'm calling this one analyzing airline operational efficiency using Python. So looking at operations of different airlines, what are causing delays? Can we prevent delays? Can we make airlines more reliable and more dependable in terms of, I think they're very reliable. In terms of departure times and arrival times, can we make that more reliable? I think the service itself is very reliable, but sometimes, uh, sometimes there's a lot of delays in the airline business. So let's get into it. And why would we even do this type of analysis? Is a bunch of reasons: to reduce costs, increase profitability, increase efficiency. Right? Anytime we try to optimize something, whether it's supply chain management or managing a portfolio of assets, we try to optimize it, right, and make it as efficient as possible. Reduce fuel consumption, save people's times, save people's frustrations, improve passenger experience. What else? And improve efficiencies, process improvements, air route optimization, dynamic scheduling, efficient air traffic controlling. There's a variety of reasons, right? The list goes on and on. So I have some notes here, share that with you guys. And this is the data set. So I found this data. I go down here. It actually came from this thing right here. Okay, so you go here and download the data and do all the analysis for yourself. Let's see what this thing looks like. Set this up a couple of days ago. Yeah, this is it. I just clicked on this button down here and you get all the data. So that's it. So you can download and uh, download the data to your desktop, just like I did. So let me go ahead and refresh this. Just to show you how everything works. So I'm pulling in the data. It's actually three files. It's a file with a bunch of flights, airports, and information relative to the airports, and then the airlines themselves. So I think the biggest is this one because it has all kinds of like arrival flights, departure flights, the city it's going to, the city it's coming from, details about um, was the flight delayed, was it on time, all kinds of details like that. This airports is a list of a whole bunch of airports all across the United States, and then specific airlines. So this is where you'll have the JetBlue name, American Airlines, and what else? Southwest is a whole bunch of them, right? So I'm pulling in the data right there and creating a data frame and doing some mergers on the data too, right? So when you have three separate files and you want to combine everything together, you always have to join on something. So just like you would see in the world of SQL, you have an inner join. Usually you can have a left or right join too. If you use the left join, remember it's going to take everything from the left data frame or data set, whatever you're working with, and then combine all the matches on the right. If you have the right join, it's still the opposite, right? You're getting everything on the right, only the matches on the left. If you have an inner join, it's only taking the exact matches, right? So if you think one data set has more information than the other, you want to do a left or right join and just set those up, align those appropriately. If you do the inner join, you're only going to have the exact matches, okay? So just be aware of that. So here's the final merge data frame. Looks like this. We have year, month, day, 1 million records, right? And 47 columns, right? So it's always rows, columns. So 1 million rows, 47 columns. And this is what it looks like. So we have a good distribution of pretty much everything here: latitude, longitude, airport, airlines, IATA codes. So this, I guess, is the abbreviation for the airport. And then I think, oh yeah, here's the airport name: Seattle, Tacoma. Okay, so they give you everything, right? Pretty rich data set. So we're going to look at 10 key questions and try to answer these 10. Which airlines have the most delays? Which airports experience the most delays? What are the busiest air routes? How does weather or security or air system delays impact performance? Which airline has the best on-time performance? What time of day has the highest performance or highest delay, right? And which has the least? We're going to look at those. A couple more questions. How do delays change per season? How long are the taxi times at different airports? Which airports handle the most traffic. And question number 10, how do we optimize air travel, or at least make some kind of process improvements right here? So decrease delays and increase arrival times. Okay. And the first thing we're going to look at here, this is mostly a lot of plots and charts based on this data. And I always say a picture is worth 1,000 words, right? I can take 1,000 words and try to describe something, or just create a nice chart and let the image do the talking, right? So in this case, we're looking at flight efficiency scheduled versus actual time. So this comes from the data frame, right? If we look here, flights merged. If I do Control F and search for that, everything gets highlighted. So my flights merged is this data frame over here, all right? Where I'm concatenating or literally merging these two. Concat is a little bit different. We're merging these two data frames together, right? So that's where we get the data frame. And in this case, I get rid of that thing. In this case, we're going to look at a whole bunch of bins of data and try to understand just generally, like, how efficient are these airlines? We're binning the data into different bins because there's millions of records here. You saw this 1 million records. And if we just look at the distribution of everything, it's going to be scattered all over the place. But if you look at the bins, we have 50 bins where we're taking 1 million records and dumping them into 50 structured bins. And we'll still see the distribution. Most of it is like right here in the middle, right, scheduled around this number 1. But you do see a few outliers over here, right? You see efficiency negative 0.05 to negative 0.99. And this is the takeaway here. So efficiency, if it's greater than 1, the flight took exactly as long as the scheduled time. If it's less than 1, the flight was faster than expected. So we see a few flights that arrived faster than expected. Most of them were on time. We have a few delays over here with the tail of the distribution stretching over to the right. So this is a serious delay. If it gets up to 2, I think I can zoom in here. Yeah, if I get up to 2, that's pretty serious delay. But there's not too many of those. It's just a handful. And then what else? So greater than 1, the flight was delayed. Let me rerun this just to rebuild that chart. This will be fast. So efficiency 1, it's on time. Less than 1, fast. And greater than 1, then it's kind of slow, right? And you see the breakdown here. And we can see the distribution too. This is a box plot. We can see the upper quadrants. This is Q1 through Q3. So a lot of flights were on time or a little bit early, but there were some significant delays. If you go over here, the efficiency is pretty poor. Remember, anything greater than 1 is bad, and we get 1. This must have been, I don't even know what that was, four times less efficient than these over here. So that's that. Okay, so here's the next chart here. Check the overall distributions of delays. Okay, so that's what this is going to show us. And again, we have the box plot, so we can see the distributions Q1, Q3. The upper ranges kind of extend pretty far over here, 1,400 minutes of delays. A lot of the delays are about 45 minutes, kind of peaks around, delays in minutes, yeah. Just a short delay, and then it goes in terms of hundreds of minutes up to 50 to 99. We had 8,800 instances. We had about 3,000 instances where the delay was over 100 minutes. Then we get into 200 minutes, and we had a couple that were way out there. So a delay of over 1,000 minutes. So that sounds pretty bad. I'm glad it wasn't on that flight. So how do weather and security and air systems impact performance? Let's refresh this. I mean, you can already see the chart. I'm just refreshing just to get just to show you that the code actually works. Otherwise, I mean, you can see these charts out there. Everything works. I'm just running it in real time just so you know, like, who knows what. I think copy and paste some picture and just superimpose it. Like, all the code is in full working fashion here, and it's 100% correct. All right. So I like to demo just how the code works when I put these videos together. So you can see airline delay. That contributed about 30% of the overall delays, about 42.8% late aircraft delay. So I think these are all connecting flights, right? So if your flight is late and you need that plane to travel somewhere and you're waiting for the other guys, then there's not too much you can do about it. You have to wait for that plane to arrive before you go. And two major cases, I think we're seeing like almost 75% of the time we're waiting for other airlines. That is the majority of the delays. Security delay is 1 fraction of 1%. weather delay is only it's only about 4.5%, and air system delay. So I'm not sure what that is. Maybe a technology issue, and the flight couldn't take off because of some tech issue. I think air system delay or whatever, something in the system wasn't working right. So most of the time, it's not even weather related. You're waiting for other flights most of the time, 75% of the time, or there's an air system delay. In a couple cases, there's a security delay, and in some instances, there's a weather delay, right? So that's what you get from that. So let me refresh the next chart and take you through that. Okay, so these are average arrivals, average arrival delay by airline. So American is doing something pretty bad here. They're really need to level up their game a little bit, and Virgin America is doing it right. Okay, and then here's the breakdown in sorted order of each major airline and number of delays. So the next chart here we can see is counts of flights per airport. So which airports handle the most traffic? Hatfield and Jackson Atlanta International had 6,000, over 6,000 flights. The next busiest was Dallas Fort Worth and Chicago O'Hare, then Denver, LA, and the least busy airport of the top 10. I think we're looking at the top 10. Is that it? Yeah, top 15. Top 15 airports. Newark in Newark Airport in Newark, New Jersey was the 15th busiest airport. Okay, so most delayed airports. So we know the busiest airports were the most delayed airports. Kodiak Airport, I believe that is in Alaska, I think, and then Bethel Airport. These guys are struggling. They have a lot of delays. Elko Regional Airport, I'm not even sure what that is. Nome, I'm pretty sure that's Alaska. Probably some weather delays up there. The weather can get pretty bad in Alaska. But none of these, this is interesting because none of these are real big major airports. So I think the major airports where most of the air traffic occurs actually don't struggle with delays. You have these smaller, I would guess, regional airports, because I don't even recognize any of these names. The regional airports actually tend to have the biggest delays. So that's kind of interesting, right? So let's look at the next one, optimize flight scheduling. Okay, let's look at a heat map based on the day of the week and the scheduled departure or arrival and descending order. Is there a delay? These are all negative, right? So the flight actually got there early. This is 37 minutes early down to 25 minutes early, and these are the delays down here. So these are the best on the top, and these are the worst days times to fly. Okay, and that is a blank cell. I can just delete that. But if you look at it, so the breakdown here, what is it? Oh yeah, so one is Monday and 7 is Sunday. So the best time to fly Monday, Tuesday, and at 22 p.m. Oh, that's like 10 p.m. That is probably the best time to fly. You're going to get there early, right? So if you fly on the Tuesday and you leave at 2200 hours, that's 10 p.m. You're going to get where you're going pretty quick, right? Another good time to fly is Sunday, right? 7 is a Sunday. You can see that over here. 7 is Sunday. 1 is Monday, and that is 1:35 a.m. Okay, so that makes sense. If you're on the plane at 1 a.m. in the morning, you're going to get to your destination quicker. These are the worst times to fly. So Monday, Tuesday, Wednesday, Thursday. Thursday would be 4, and this is 23 p.m. So 11 p.m., almost midnight. So if you're flying a Thursday, trying to get back home, probably consultants traveling for work, they go in to see their clients on Monday, fly back Thursday on the red eye, and these guys are going to have some serious delays. 400-minute delay by the time you get home. It's probably almost Friday night. You're leaving Thursday night, but it's probably Friday night before you actually get into bed. And then Monday at 8 p.m., that's another bad time to fly, right? So Monday at 8 p.m. and then Sunday is 7, so 6 would be Saturday at almost 3 p.m. That guy has a lot of delays on that flight too, so don't fly it on a Saturday at almost 3 p.m. in the afternoon. Don't do that because you're going to have a lot of delays, okay? So reduce taxi out time. So refresh this chart. I don't have to do it, but just to show you how it works. So taxi out time is the longest at Jackson Hole Airport, so I think that is in Wyoming, and Kalamazoo Battle Creek International has the worth the 15th. I think it's his top 15 worst taxi out times. Yeah, I got 15. And this could be anything. You could change these to be 10. You could change it to be top 5, top 25, whatever you want. Just pick 15. That's a good number. So this is the worst, and this is the 15th worst. That's how you'd interpret that. Then we have optimized shortest flight paths. Okay, so refresh that. The shorter the flight, the less the delays. This is only 31 miles, so Wrangell Airport to St. Petersburg. So these are pretty short flights. And by the way, if it's a short flight, there's very few delays, right? Because you're not going very far. If you have a flight that's thousands of miles, like you see down here in the bottom, then there tends to be more delays. So 63 minute of delays. This one is pretty far and has actually got there like 3 minutes ahead of schedule. And this one is pretty far. It got there just 12 minutes late, not too bad. But you can see like over here, the shorter the distance, less delays, because what can happen, right? You're only going 69 miles. That's not too far. So that's that. Let me plug in here and keep going, keep plugging away. I'll plug my computer and keep plugging away with the analysis. Just a couple more to get through, and then we're done. Okay, I think this stuff is pretty cool. Hopefully you agree. So this is, again, looking at 20 busiest airport routes. So LAX to JFK is number one busiest. JFK to LAX. Almost as busy, right? If you're going to go there, you're going to come back. SFO, that's San Francisco to LAX. LAX and SFO, if you go there, you're going to come back. So these are all round trips, right? This is pretty predictable. Los Angeles to LAX, LAX to Los Angeles, right? So wait, Las Vegas. I think it's Las Vegas. And then Atlanta to LaGuardia is the 15th busiest travel routes. Okay. What else? Got a couple more here. What time of day has the highest delays by day of the week? Okay, so this is when you want to schedule your flights or avoid scheduling your flights, right? Sunday has the most delays. Saturday is pretty close, so Saturdays and Sundays don't fly on Saturdays and Sundays. Mondays and Tuesdays have some delays, not as bad as Saturday and Sunday. Thursday has the fewest delays, so go ahead and book your flight on a Thursday, and you should get to where you want to go without worrying too much about whether or not the plane will be on time or delayed. Sunday, almost guaranteed. Thursday, you're pretty much all set. And then the hour of departure matters too. So the day matters and the hour of the departure matters. If you leave at, this is 3 o'clock in the morning, you're going to have delays. I would guess the biggest delay is just finding pilots that are awake at 3 o'clock in the morning. I don't even know who's flying at that hour, but apparently there's quite a few delays. So don't book your flight at 3 o'clock in the morning. I think that goes without saying. You shouldn't be doing that anyways, right? Like what is that important? But the next biggest delays totally makes sense. This one, I don't know if I really agree, but I didn't change the date at all. So it is what it is. Average delay is 34 minutes if you fly at 3 o'clock in the morning. These make a lot more sense to me. But the data is what it is, right? Like I didn't change anything here. This makes a little bit more sense. So this is 1,800 hours. So what is that? 6 p.m. and 7 p.m. and 8 p.m. Right, 2,000 hours, and then 21. That is 9 p.m. And then it kind of dies down because people are getting to where they need to be at that point. It's the end of the day. Air traffic is slowing down, and people are either where they need to get to, or they're on the last flight out for the end of the day. So these make sense. Don't book your flight at 8, 9, 10 o'clock at night, and please don't book it at 3 o'clock in the morning. That's just insane. I don't know who's even doing that anyway. And then I think, yes, I used one more tool down here to try to predict if there will be any delays. So this model by Profit, this is called a Profit model. This is a time series prediction tool. It helps us to predict any type of thing like future stock prices, weather patterns, retail sales, customer demand for your products. If you're selling something, it'll help you make predictions about your what am I trying to say? Your products, right? Whatever you're selling. So demand and sales and things like that. So Facebook is great for making these types of predictions, and it's running the Profit model right now and feeding in basically just two things: the date and then the whether or not there will be a delay. And by the way, I think airlines do a fantastic job of providing outstanding service. I've never had any any problems. I have had a few delays in my time, but no real major incidents, thank God. And air traffic incidents, I mean, fatalities are very low. You've seen a couple in the news recently, which is very unfortunate. But I think overall, like they do a very good job of getting people where they need to be on time, um, very consistently, very persistently. But there are delays. But when I was doing all this analysis, I found out that these delays are very hard to predict. And I got several models trained. I didn't even showcase them here because the prediction wasn't very accurate. It only got to about 70% accurate. So in the machine learning world, 70% is not great. I didn't even show it here because it's not very good at making predictions. 30% of the time you'll be wrong. 70% of the time you'll be fine. But 30% error rate is actually like a pretty big error. So I took out all the machine learning models because it's very, very, very difficult to predict whether or not a flight will be delayed. And I'm just showing one model here. This is a profit model. And you can see it's almost a flat line. Like across time, you've seen historicals. Here's the delay. Here's not a delay. Here's the delay. Here's not a delay. And it's just very difficult to predict this. And you can see the main line. You can see the upper bound and the lower bound is going like this, right? It's diverging. But the primary prediction, if you don't look at those intervals, if you just look at the actual horizontal line, that navy blue line, it is pretty much close to zero because the model just couldn't learn and couldn't make very accurate predictions. It's very, very random whether or not a flight will be delayed or not delayed. Most of them are not delayed. If they are, there's a few reasons for that. We saw that initially at the beginning, right? What were the 4 primary reasons, or 5? Security was one. Here it is. Late aircraft delay. You can't control these things, right? So try to predict delays is next to impossible. You can't control airline delay. You can't control late aircraft, right? If you're taking a connecting flight and a flight is late, you're going to be late. You can't control it. You can't change it or modify that. Air system delays. I think this one could be improved on. That sounds like more of a technical error or human error, which could probably be improved. This is a weather delay. There's nothing you can do about the weather. It is what it is, right? And if the aircraft is late, it's just late. What can you do about it? There's nothing you can do. So to make predictions is extremely difficult. And originally I tried to do that. I was going to make this video have a slightly different topic. It was going to be around trying to predict delays in the airline business, but it turns out it's extremely difficult to do that. So I just changed the topic to analyzing airline operational efficiency. And I think that's a more effective topic and more interesting because those delays are just next to impossible to predict. So it is what it is, right? You just go with it. I wish we could make these predictions, but we can't. But nevertheless, it's pretty interesting to study this data from these different perspectives. And I think we did answer those 10 questions that I brought up to you before. If I go back and just look at those 10, where is it over here? Towards the beginning, right? Where was it? Yeah, right here. Okay, so I think we answered these 10. So I think we're good to go. I'm going to download this file as an HTML and I'll share it with you guys. And I will see you in the next video. Okay, thanks. Bye.